Over the years, SDRG Controls has had a number of opportunities to address controls on small, electric trains. These trains could be small amusement rides, service vehicles, plant service vehicles, and the likes. These were not large locomotives, passenger or freight trains which require railroad specialists. They were small trains or transportation devices which operate on small gauge track. This sign shows a typical route for a small tourist trolley. These small-size vehicles are used for tourist or materials handling in a small, confined area. They used similar devices to locate and direct them. They were powered by electric motors and used many safeties, switches and interlocks to ensure safe operation. Some would cross roadways within a plant or work area. These would require warning lights, crossing arms and similar devices to ensure the safety of people and motor vehicles such as cars and trucks. We also supported the crossing arms and signaling devices outside the vehicles. Come along with us to see some of our train adventures. Several applications use trolleys, such as the one shown in the background of this photo, and other trains do not carry passengers. Ones like this require a different level of safety than other applications. Since the ones shown here carry personnel and ride on streets and paths which have other large vehicles, they must take passenger life safety into account. They have more interlocks, traffic control devices and methods to keep the trolley away from motor traffic, and must watch and plan for pedestrian traffic. Industrial applications which deal only with operators and other mechanical equipment within a plant have less strict road hazard requirements. They still may have moving crossing arms, but the event of an incursion is not as stringent. In both cases, collision avoidance is important, but the danger of an accident is not as serious. Moving materials within a manufacturing plant does not require as many controls and interlocks. This photo shows a newly manufactured SDRG control enclosure installed behind the park bench where riders wait for their trolley. In the background is the sign, close-up shown previously, which shows the trolley route. The worker has the street blocked off while construction and testing are performed. This application required extra safeties because there was pedestrian traffic, motor traffic, and was located in a tourist area. Tourist areas require extra safety measures because people and vehicles in these areas are not always attentive to their surroundings, as it is a leisurely environment. Extra interlocks, measurements, and safeties were employed to compensate. Inside the trolley car, an operator stood at the front of the car to observe the traffic and obstacles ahead. He had a clear view of the traffic, as well as the passengers both inside and outside the car. He could control the trolley's speed, but the trolley had to remain on the tracks, which forced it to follow a predetermined path. Extra sensors were employed in this application to detect vehicles, track directions, and the trolley position to avoid accidents. This installation included an RF sensing system to detect objects to aid with accident prevention. Sensors were buried underground, along the walkways, and along the roadway for object detection. Moving arms, lights, and barricades were used for accident avoidance. The trolleys appeared to be old-fashioned trolley cars. But, in reality, they were modern devices hiding sophisticated controls, wiring, and sensors. The box in the picture shows the electronic transmitter which aided in identifying and tracking the trolley. It helped to identify which trolley it was and where it was located. This aided tracking the trolley and determining whether it was on schedule or running behind. Note, there were many more wires in this small trolley. The trolleys operate on dedicated tracks and follow a predefined route, but the movement and braking of the car was tracked and monitored to ensure there were not unexpected events. If there were, they could be identified and compensated for before a problem occurred. Braking and lights were used to keep everything on schedule. The trolley cars ride on tourist town streets. The tracks are embedded in the roadway and include switches and sensors to detect and direct the cars. In this photo, technicians are working on one of the switches which controls the direction the trolley will move. Off to the right in this photo you can see one of the boxes which SDRG made to control this switch. It's under the palm tree. Other similar boxes are spread throughout the rail route. In other applications, such as in a plant, devices are spread throughout the facility. They do not directly control the vehicles, as these do. They mostly monitor for movements and control the traffic. In plant applications, we try to keep the motor and rail traffic separated from each other. Within plants and work sites, our equipment attempts to keep personnel and vehicles separated from each other. This image shows a movable arm keeping people and motor traffic separated from one another. The arm must detect the vehicle's approach and close the arm before the personnel and equipment collide. Timing and detection are the key factors in an operation like this. Many times the fork truck operator drives fast so that he can show his boss how much work he can get done. In such cases, the detection and operation must be fast enough to prevent an accident. This issue is further complicated by the pedestrian not always paying attention to where he is going. Safety requires everyone's attention. Within plants and work sites, our equipment attempts to keep personnel and vehicles separated from each other. This image shows a movable arm keeping truck and forklift traffic separated from rail traffic. In this case, the railroad traffic may not see the other traffic, and they cannot stop as quickly as the others can. Again, the arm must detect the crossing approach and close the arm before the vehicles collide. Timing and detection are the key factors in this operation too. Many times the forklift and truck operators drive fast so that they can get under the crossing arms before they close. In such cases, the detection and operation must be fast enough to prevent an accident. Again, safety requires everyone's attention. So this has been a trip through some of SDRG Controls' small rail and related traffic control type projects. It is an interesting trip around our projects, which are somewhat different from the normal testing, manufacturing, industrial controls projects. These still involve the design, build, test, and documentation parts of projects, with their own little twist. We hope you enjoyed our journey through this area, and will return for more interesting and exciting videos.